welcome to Count Her Math. Today we are going to cover real numbers and their properties. Firstly, you might be thinking, what do you mean by real numbers? Are there fake numbers? Well, there kinda are. We call them imaginary numbers, but we will not concern ourselves with them today. So a real number is a number that can be found on a number line. A point on a number line is a coordinate, and each coordinate is a unique value. The coordinate 2 may be written as 4/2, but the value is still the same and therefore is a unique value. Now, inside of the set of real numbers, there are subsets of other number groups. Starting with the set we used when we did the sets video, natural numbers or counting numbers are the numbers 1, 2, 3, 4, etc. The next set is the whole numbers. This set contains all natural numbers and 0. The only difference between whole numbers and natural numbers is that 0. Our next set adds in negatives of natural numbers, and that will give us the set of integers. Integers include all natural numbers, all whole numbers, and all the negatives of the natural numbers. We are going to use integers to build the next set, the rational numbers or fractions. A rational number is an integer divided by an integer as long as that denominator isn't 0. All of these numbers can be found on a number line, making them real numbers. There are also many real numbers that can't actually be shown by dividing two integers, but we can still find them on the number line. Therefore, they are real, but they are not rational. We call them irrational numbers. Some examples include pi or the square root of 2. These are still under the umbrella of real numbers, but are separate from all those other sets. Now let's talk about exponents. I have an entire video on exponent rules with examples, but I'm still going to cover the basics here as well. An exponential expression consists of a base and an exponent. The exponent tells us to multiply the base by itself that many times. When we read this, 5 to the power of 3, we would write 5 times 5 times 5, and that would evaluate to 125. I do want to point out that when something is to the second power, we say it's squared, and when something is to the third power, we say that it is cubed. One trick to remember that is that a square is a 2-dimensional shape and a cube is a 3-dimensional shape. If you have questions specifically about exponents, check out my other video. I'll put a link in the description. On to orders of operation, but with algebra. The rules are basically the same, but it just looks a whole lot more intimidating. So let's go over our rules real quick. If there is a fraction bar or we have parentheses or brackets, we're going to do these first two steps. Step 1, work through the numerator and the denominator separately. We'll work through the top of the problem and the bottom problem before we try and combine them. Step 2, every time we find a set of parentheses or brackets, we're going to apply all the rest of the rules before we move out of the parentheses, and then we'll move on from there. And I'll show a couple of examples of what that looks like. If there are no groups or we're working inside one of the groups from before, we'll first simplify all powers and roots in the problem working from left to right. And if we remember from PEMDAS, it used to be parentheses exponents, powers and roots are highly related. Just kind of like multiplication and division and adding and subtraction, power and roots have that same kind of relationship. Then we will move to the next step, which is to do multiplication or division from left to right. Once that is done, whether it was inside the parentheses or just the entire numerator or denominator, we're going to move on to step 3, which is negations, addition, and subtraction. Negations is a fancy way of saying apply negatives. And we're going to do all of these from left to right as well. And then once we finish working through each of the parentheses, each of the brackets, the bottom steps, when we finally have a fully simplified numerator and a fully simplified denominator, that is when we will finally try and divide them together and see what we can reduce or simplify from there. So let's look at some examples. So our first example, we have negative 3 cubed plus negative 5 all over 2 times negative 8 minus 5 times 3. We have a whole lot of stuff going on here, so let's go through our orders of operations and work through this problem. We do have a fraction bar, so we're going to work through the numerator and the denominator completely separately. Then let's look at the next part, which is seeing if we have parentheses that we can work within. We do have some parentheses in here, but they're not anything I can work with. These parentheses are really acting as multiplication placeholders for us. So we have multiplication in all of these gaps here. between the number or the operation and the parenthesis, that's going to be multiplication. If there's nothing to multiply, nothing obvious to multiply anyways, that's where we have our hidden ones. So let's add those hidden things in real quick just to help us visualize what we're doing. So we have the fraction bar, we're doing things separate. We don't have any parentheses we can really work with, so let's move into the next set of steps. Let's look just at the numerator first, where we're going to simplify all powers and roots. We have one set of powers here, -3 to the third power. Now that means I need to multiply -3 by a factor of 3, which would look like -3 times -3 times -3. And this comes out to be -27. This is equal to +9. And then we multiply that by -3, we'll get to -27. Alright, perfect on the numerator. Now let's check the denominator to see if it has any powers or roots. It does not, so we don't need to change it here, so we'll just leave it for now. Our next step is to do multiplication and division from left to right, and we have a lot of multiplication going on. First we have our -1 times -27, or if we wanted to look at it without the added in helpers, it would simply look like -27. This is multiplication, so it's going to be part of our multiplication steps. And then negative times negative is a positive, so that's going to leave us with +27. Then we have +1 times -5. It also could just say plus -5. When we have two operations side by side like this, that's going to tell us that we're actually subtracting. We can also think about the fact that it's +1 times -5, which would leave us with -5. Now let's look at multiplication and division in the denominator. So 2 times -8, well that's going to be -16, and -5 times 3. We can either look at the minus as just bringing it down and do 5 times 3, or to look at it as this is a -5 multiplied by 3. Either way, we're going to see that we need to put -15. Now we're at the part where we need to do addition and subtraction. So 27 minus 5. Let's grab a new color. 27 minus 5 is going to give us 22. And -16 minus 15. So I'm at -16. I'm going to get even more negative. I'm going to go back 15 more. And that's going to bring me to -31. Now this could be considered your answer, and it is correct, but part of our orders of operations is to do that negation, which means that we actually want to pull the negative out of the 31 and just apply it to the entire fraction, which would look something like this. So we have -22 over 31. Alright, let's look at another example. We're being asked to evaluate this expression when x is equal to -2, y is equal to 5, and z is equal to -3. Our first step is to rewrite this, plugging in those values. Now that we have all those values plugged in, we're going to start working through our orders of operation. First, we have a fraction line, so we do need to work through the numerator and the denominator separately. The next thing we're going to look for is parentheses and or brackets in either the numerator or the denominator to simplify out. We have one set of parentheses up in the numerator that we can play with, that -2 minus 5. And -2 minus 5 is -7. So that step is completed. Now we're going to look towards our next step, which is to simplify all powers and roots. We have one power in here. We have -7 all squared. Take note that the negative sign is within the parentheses, which means I'm multiplying -7 times -7. And a negative times a negative is a positive, and 7 times 7 is 49, so -7 squared is +49. I'm gonna fix that right in this line and save us a little bit of space. Alright, we've made it to 4 times 49 plus 4 times 5 all over -3 plus 4. And we are now on the step where we need to do multiplication and division from left to right. And we do have multiplication up top, so let's go through and multiply those out. We have 2 times 49, which is going to give us 98. And we have 4 times 5, which is 20. And I'm going to jump ahead real quick in that denominator and see that -3 plus 4 is +1. And when working with fractions, anything over the power of 1, the power of 1 does not need to be written. So we can just say that this is 98 plus 20. And we've moved to our very last step, which is doing addition and subtraction from left to right. So all we have left to do is 98 plus 20 and get 118. And we're not going to write that it's over 1 because that's going to be unnecessary. So our answer is simply 118. Or 118, I should say. Moving on back to focusing on real numbers. Real numbers do have an assortment of properties that are always true, and some of them are going to seem super obvious when I mention them, but it might become more hazy when we mix variables in, so we want to make sure we got them down packed with numbers, so when we start working with variables, we have everything under control. Our first property is the closure property, and this tells us that a plus b or a times b is a real number as long as a and b are already real numbers. An example would be 4 times 5 is 20. 4 is a real number, 5 is a real number, and that means 20 has to be a real number. Our next property is the commutative property, and this says that a plus b is the same thing as b plus a, and a times b is the same thing as b times a. Essentially, this one tells us the order in multiplication and addition does not matter. I can say 5 plus 2, or I can say 2 plus 5, and in both cases it will equal 7. Our next is the associative property. So this is a property about grouping. I can say a plus b plus c is the same thing as a plus b plus c. This also works with multiplication, where ab times c is the same thing as a times bc. An example would be 2 plus 3 in parentheses plus 1 is going to be equal to 6, and 2 plus 3 plus 1 is also equal to 6. What's important to know about these two properties here is that the commutative property is all about the order, whereas the associative problem is all about the grouping. Our next property is the identity property. Now this one is telling us that a plus 0 is still a and a times 1 is still a. This one should be probably pretty straightforward for everybody. We've been using these guys for a very long time. If I have 3 apples and I add no apples, I have 3 apples. And then 3 times 1 is also 3. Now let's move into one that's a little more in-depth. We have the inverse property, and this tells us that a plus negative a equals 0, and we also have a property with the reciprocal, where a times 1 over a is equal to 1. The examples of this hopefully will make it a little more clear. If I have 7 and I add negative 7, I'm going to move myself right back to 0. I could do that in reverse as well, and if I had negative 7 and I added 7, I would pull myself back up to 0. In both cases, it ends up at 0. The multiplication one, if I had 5 times 1 over 5, it's going to equal 1. If I did the multiplication across, I would end up with 5 over 5, which would reduce down to 1. Multiplying using the reciprocal or the identity property helps us skip the step of multiplying across, then reducing. Now we have the distributive property, and this one you see a whole lot in algebra. We're going to be working with this one constantly. And this tells us that a multiplied by b plus c is equal to ab plus ac. An example of this would be 5 times 2 plus 3 is equal to 5 times 2 plus 5 times 3. If we did out the first part, it would end up being 5 times 5, which is 25. And this other side, 5 times 2 is 10, plus 5 times 3 is 15, and that would also get us to 25. And the final property we're going to talk about is the multiplication properties of 0. Anything times 0 is 0. So if we want to keep this format we have going, we'd have a times 0 equals 0. An example would be 4 times 0 equals 0. Remember, this also worked with huge things like polynomials, or the biggest thing you can think of off the top of your head. If it is multiplied by 0, the answer is 0. That's all our real number properties, so let's move into inequalities. This section's going to briefly cover the inequalities, specifically in reference to a number line. We have a less than and we have a greater than sign to show if something is bigger or smaller. I was always taught that the alligator always eats the bigger number, and then I remember which sign is called which because the less than sign starts small and the greater than sign starts big. So if I say A is less than B, I'd put A, and then the sign that starts small gets big for less than B. An example would be 5 is less than 7. Our alligator's eating the 7. We can also say A is greater than B. We're going to reverse the sign, so now we have A is the big part to the little part, or A is greater than B. In the example, we'd flip this around, and now we're going to say 7 is greater than 5. The alligator still wants to eat the bigger number. Another thing we have that we can do with inequalities is that we can also say less than, or equal to, or greater than, or equal to. This is helpful for us because I can't say that 5 is less than 5, because that's not true. But I can say that 5 is less than or equal to 5. We show this by putting a little line under the inequality. The next concept is going to be absolute values. An absolute value shows the distance from 0 on a number line, and distance can never be negative. An example I like to use with my students is if I'm driving to my local Dunkin' and it is 5 minutes away from home, I have a distance of 5 minutes to drive. When I'm driving home from Dunkin', I don't get to drive negative 5 minutes, it is still 5 minutes home. So in both ways, my distance is a positive 5 minutes away. And we write absolute value with these two lines with the number in the center, or in this case using A. So this says the absolute value of A. And our rule is the absolute value of A is equal to A if A is greater than or equal to 0, but it is negative A if A is less than 0. A general idea is we often just think the absolute value is the positive version, and that will get you through the day, but let's look at what it actually means using this rule real quick. Let's take these two examples. Our first one, the absolute value of negative 3. Now, using the whole is just the positive version, the answer is 3, and that is correct. But let's look at using this rule. So if the absolute value of negative 3, well, A is negative A because A is less than 0. So I would rewrite this to say negative 3, where the negative 3 in the parentheses is our original A, and the negative outside the parentheses is referencing our rule over here. And a negative times a negative is a positive, so we still come out to an answer of positive 3. The absolute value of 5, the rule is very straightforward here. If A is positive or 0, it is simply A, and A is 5. So nothing changes to A if A is already positive. Now let's take a look at the properties of absolute value. Our first property tells us that the absolute value of A is always greater than or equal to 0. Our second property says that the absolute value of negative A is equal to the absolute value of A. So that tells us the absolute value of negative 3 is the absolute value of 3, which both are equal to 3. We then have the absolute value of A times the absolute value of B is equal to the absolute value of AB. That one works because if we have two positive numbers and we multiply them together, we're going to end up with a positive number. We also have the absolute value of A over the absolute value of B is equal to the absolute value of A over B. Same idea here, a positive divided by a positive is a positive, so we can put them together to make it into one unit. The last property is called the triangle inequality. Is the absolute value of A plus B is always less than or equal to the absolute value of A plus the absolute value of B. We can also use absolute value to tell us how far apart two numbers are from each other. So not only will absolute value tell us how far away a number is from 0, but we can also use it to find the distance between two numbers that are not 0. So if we need to know the distance between two numbers, we're going to take the absolute value of the numbers subtracted from each other. And it does not matter which order we do this in. On a number line, if I have point P and point Q, and we're going to call these coordinates A and B respectively, in order to find out the distance between P and Q, I would subtract A minus B or B minus A and take the absolute value of the answer. Let's say I want to find the distance between negative 3 and 5. And I have two options to do this. I can say the distance is the absolute value of negative 3 minus 5, or the distance is the absolute value of 5 minus negative 3. Over here, negative 3 minus 5, that's going to give me the absolute value of negative 8, which is positive 8. Over here, 5 minus negative 3 is the same thing as saying 5 plus 3, which is the absolute value of 8, which is 8. In both cases, the distance between negative 3 and 5 is 8. And that covers all the concepts in this section, so now let's look at some practice questions. Our first question says to evaluate this expression, -4 times 9 minus 8 plus -7 times 2 to the third power. We need to keep our orders of operation in mind. We do not have a fraction bar, so we don't need to worry about that step of order of operation, but we do have parentheses. So the first thing we have to do is simplify that 9 minus 8 in the parenthesis. And 9 minus 8 gives us 1. And that step is complete, and that finishes off the parentheses that we can work with. So now let's move into the next part, simplifying any powers or roots. On the end here we have 2 to the third power, so we do need to simplify that out, and 2 times 2 times 2 is 8. Our next step is to do multiplication and division going left to right. Our first multiplication is -4 times 1, and a number multiplied by 1 is simply itself, and a positive 1 times a negative gives us a negative, so we're going to end up with -4. Our next set of multiplication is -7 times 8. A negative times a positive gives us a negative, and then 7 times 8 is 56. Our last step is to do negation, subtraction, and addition from left to right. The first thing that I'm going to fix here is that I have a plus negative, and we do not like seeing a plus a negative, so I'm going to adjust this to be subtraction. And -4 minus 56 gives us -60. Our next question is still asking us to evaluate an expression, but under these conditions, we have that p is equal to -2, q is equal to 8, and r is equal to -10, and we need to evaluate this for 3q all over r minus 5 all over p. Our very first step should be to enter in these values into our expression so that we can calculate it. Alright, we had a small error in our problem. It's actually p is -4. We could have solved it with the -2, but I prefer to solve it the way I already solved it on my papers. So first let's look this over. We have two fractions being subtracted from each other. So when we're talking orders of operations, we have this fraction bar telling us that we need to do the numerator here separately from the denominator here, and a fraction line here telling us the same thing. The 5 over -4 is already fully simplified, so we don't really have to worry about that one too much. But we do have some multiplication going on in the numerator over here. So 3 times 8 is going to give us 24. And we move our problem to look something like this. Now we need to subtract fractions. To subtract fractions, we have to have the same denominator. And one thing I'm going to do here to make my life a little bit easier is I'm going to cancel out this minus -4 here. So in order to do this, first I can pull a negative out of the denominator to bring it to the front of a fraction to make it a little easier on me. So what that would look like is I would say -5 over 4. Instead of saying minus -5 over 4, I'm going to say plus 5 over 4. And on the 24 over -10, I'm going to do the same idea and pull the negative out of the denominator. That way I have -24 over 10 plus 5 over 4. Now this is a little easier to work with. We haven't changed anything, we've just manipulated things to work with us better. So now to add these fractions, I need to have common denominators. And the first number that both 10 and 4 go into is 20. So that's what we're going to change our denominator to. And we need 10 times 2 in order to get this denominator to be 20. So I'm going to multiply this entire fraction by 2 over 2. And 4 times 5 is what gets me to 20. So on 5/4, I will multiply the fraction by 5 over 5. This is going to allow me to get two fractions that have the same denominator. And I end up with -48 over 20 plus 25 over 20. These are the same value as they were before. I've manipulated them, that way they have the same denominator, so I can add them together. Now our last step is to add those numerators together. I'm adding -48 plus 25. And -48 plus 25 does equal -23. And our denominator stays the same. This is already in lowest terms. There's no number other than 1 that's going to go into 20 and 23, so this is our final answer. Our next problem is using the same values for P, Q, and R, and we're going to plug them into this expression instead and evaluate this one. Just like before, our first step is to plug in the values into the expression so that we can go through and evaluate. Alright, with all the values plugged in, We can get started working on our problem. So first, does it have a fraction line? Yes, it does. So we need to work the numerator and the denominator separately. Because that denominator is pretty simple looking, I want to start there. I want to start by saying negative 10 plus 8 is negative 2. Get that said and done and out of my way. And because the order of operations says I have to do the numerator and denominator separately, it does not say I can't do the denominator first. We just tend to do the numerator first. But this way also follows the rules. Now we need to look at parentheses and brackets. We do have a set of parentheses here where it is 4 plus negative 4. Now if we remember back to before, this is also saying a plus negative a, which was one of our properties, and it was the inverse property. If I add the opposite together, I end up canceling myself out and getting back to 0. If I'm at 4 and I add negative 4, I'm going to backtrack back to 0. Then our next step is to look at powers and roots. We're also going to use another property right now. We're going to be using the multiplication of 0 property, where anything times 0 is 0. That includes if we're doing powers, because this is telling us to do 0 times 0 times 0, which is 0. Then if we look real quick to the left, we have that 3 there. That's going to end up being 3 times 0, and it's going to all cancel out and give us a big ol' 0. Now that does technically skip a step real quick because I'm supposed to do my multiplication from left to right, but these terms were completely separate, so doing that one first isn't going to adjust the answer. So let's go back and do that 3 times negative 4 so we don't forget about it. And 3 times negative 4 is negative 12. Plus 0 means that I don't need to do anything, so we don't write plus or minus zeros really ever. It would just take up extra space and accomplish nothing. So when we end up with something like this, we just drop it off and pretend it was never there. So now I have negative 12 over negative 2. Both of these are fully simplified, so I can finally divide that fraction line. A negative divided by a negative is a positive, and 12 divided by 2 is 6, so my final answer is a positive 6. Here we're not really trying to evaluate anything. All we need to do is identify what property is being used in this statement. And let's think back to our properties real quick. We have one that has to do with grouping and one that has to do with order. This one, the group stays the same, but the order changes. And the property that has to do with the order changing is the commutative property. Moving right along, we need to use the distributive property to evaluate this, but it wants us to do it mentally. Meaning not put this into a calculator, not write it out, being able to manipulate the distributive property to figure out the answer. Now it's really hard to do that over YouTube, so I am going to write it down because that's the only way I can think of how to show it to you through this form of media. So if we have 72 times 17 plus 28 times 17, our distributive property is going to tell us that I have to do 17 72 times and 17 28 times. Let's write down what that looks like. So what we end up with is 17 72 times and 17 28 times. So we could say that we have 17 72 plus 28 times. 72 plus 28, that's 100. So we end up actually needing to find 17 100 times. Multiplying by 100s using that tens makes our lives a whole lot easier. 17 and 2 zeros. So 1,700. I really like this problem because it actually threw me for a loop the first time I saw it. Next, let's move into doing some absolute value problems, where it says to let x equal negative 4, y equal 2, and evaluate this expression. And just like before, well, the first step is going to be plugging stuff in. With everything plugged in, we can see that we have negative 8 times 2, plus negative 4, we'll take the absolute value of that, all over negative absolute value of negative 4. Again, we're going to start with the denominator in this problem because the denominator looks easier to deal with. So I have the absolute value of a negative number. The distance of a negative number is still positive, so this is going to turn into 4, but it's important to note that that negative on the outside doesn't disappear. So everything inside the absolute value sign is going to be positive. That negative won't go away, so our denominator is going to simplify to be negative 4, where the negative isn't from the x being negative 4, the negative is from the problem putting a negative in front of the absolute value sign. Now back to our numerator. Inside of the absolute value signs do function like parentheses, where we're going to work from the innermost one to the outermost one. But we don't have an inner or an outer, we just have the whole thing as an absolute value. So the absolute value of -8 times 2 plus -4. First thing we're going to look at here is powers. There are no powers. Alright, now we're going to look at multiplication. -8 times 2, negative times a positive is a negative. 8 times 2 is 16, so we have -16. Now I have plus -4. We don't want those double operations, so plus a negative is subtraction. So we end up with absolute value of -16 minus 4 all over -4. -16 minus 4, that's going to get me to -20 all over -4. The absolute value of -20 is going to give us a positive 20, and 20 over -4 will simplify to be -5. So our final answer to this is -5. Alright, so this next problem is using our number line, and it's asking us to find the distance between PQ, or dPQ. Distance can be found in two ways using the absolute value. I can do the first minus the second, take the absolute value, or the second minus the first, take the absolute value. Let's do it out both ways since we have the time. Now I can say -4 minus -1, or I can say -1 minus -4. As long as I take the absolute value at the end, we'll end up with the same answer. So -4 minus -1, well, minus a minus cancels out to give us a nice little positive. So we'll be doing -4 plus 1. -4 plus 1 is -3, and the absolute value of -3 is +3. Over here, -1 minus -4, same situation with that negative, where instead I can say plus. So now I have -1 plus 4, and that is 3, and the absolute value of 3 is 3. So regardless of which way we do it, the distance between PQ is 3. Sorry this video took so long to get out. I was trying to figure out how to do this the best way possible, and have decided doing it the best way possible takes too much time, and we're just going to do it the best I can, and hopefully we get videos out a bit faster from now on. Like, share, and subscribe if this video helped, and drop a comment if you have any questions or comments for me. Bye bye!